Hey YouTube, welcome back. Today we're talking about reliability. So in software and life in general, reliability is everything. You don't want surprises when you need your system the most. Today we will break down what makes a system truly reliable. But before we're talking about that, we need to understand why this matters. So reliable systems keep customers happy, protect your brand, and save you major headaches and dollars as well, or euros. I don't know where you are when you watch this video. And yeah, it helps you this down the road. So, what is reliability? Reliability means your system does what it's supposed to do every time, even when things go wrong. Think of a car that always starts, even in a storm. That's the goal for software too. We start by talking about some principles and a key principle of reliable systems. The first thing, each reliable system has redundant components and has redundancy, which is basically if we take an example about database and we have a client that sends request to the server and it sends request to our database. If we want to add redundancy to this database, basically we will add a backup server to store the oh, backup to store the data, for example. So redundancy, for example, it means like adding backup servers, backup databases, and basically in general, it means that you always have a plan B. Next, we have failover mechanisms. So if we took the same example before, can I remove this? If we took the same example before, we have our client and we have a load balancer. Let's add load balancer, and the load balancer is distributing the request among our servers. Let's say that we have server 1 and server 2. So a failover mechanism means that if one server fails, another takes over instantly. So no, the user will not notice. If we want to add a failover mechanism to the load balancer, we might add another load balancer server, which basically will take over. It will be on a passive mode. So it will not work until our main load balancer, let's call this one and this two, our load balancer 1 has any problem. So the client will start to send the request to the load balancer 2, and load balancer 2 will distribute the incoming request to server 1 and server 2. So the user will not like notice anything. Next, we have load balancers. Again, I did talk about it. A load balancer, if we have a client and we have multiple servers, let's say that we have a horizontally scaled system, so we have multiple servers, and we need to make sure that no server is overwhelmed with requests and no server is underutilized. Also, we need to make sure that we are sending requests to healthy servers. So because of that, we will use the load balancer. The load balancer will distribute all the incoming requests across the servers. So the traffic will spread across servers evenly and no single point of failure at all. Because if one server went down, the load balancer also only sends requests to healthy servers, so it will not send the request to servers that aren't available. And next we have monitoring and alert. So if we have a system, let's say go back with the same system here, and we have DB. Of course, a system is more complicated than that, but we just want to make it that easy. So if we have that system, we could just monitor our servers and our databases, our different services. Basically, monitoring and alerts like constant health checks means you catch problems before they explode. So if you have monitoring and alerts on the server or on the database, whenever you have any problems, you will just you will catch them as fast as possible. Graceful degradation. Graceful degradation. Sorry. So this means that if something breaks, your system still offer basic services, not just an error page. If we want to talk about this, I guess graceful degradation needs a video by itself because I think it's an important concept of and also it's a pretty important principle of reliable systems. So next we will talk about some techniques to make systems reliable. The first thing we will talk about redundant architectures. So for example, if we have our client and we have our load balancer that distribute all the incoming requests among our servers, and our server 2 or all our servers are sending a request to our DB. We can add redundant architecture. Basically, we can deploy multiple instances of critical components. Think of our web servers behind the load balancer, or also we can just deploy this in multi zones. So, for example, we can take this system, all of it, and actually deploy it again. Deploy it again in a different region. So if we have any problem with this system, this region can take in place. Next, we have data replication. So if we have, again, our same example, we have a client sends request to the servers. I didn't add load balancer to make it easy. And we have only one DB server. So if you want to add a replication, we will, let's say DB1, we will have a DB2, for example, and maybe we have DB3 as well. And DB2 and DB3 will keep copies of your data across different servers or even regions. So all the data that is available in DB1 will be replicated to DB2 and DB3. So if we lost DB1, we still have the data in DB2 and DB3. We can handle this by master-slave architecture, master-slave relationship. We will not talk about this now because I guess it's behind the scope of our video. But yeah, this is data replication. It's a technique that makes data quite reliable. Next, we have health checks and auto restart. I don't know if you know Kubernetes, but this is where Kubernetes really shines. So you can use tools like Kubernetes to constantly check if services are alive and restart them if they crash. Next, we have a circuit breakers. So in microservices, if one service fails, block it temporarily so it doesn't drag down the whole system. You can think about that. And lastly, caching. I guess I created a video about caching, so I'll just go pretty quick about caching. So you basically in caching, let's give an example. So let's say that we have a client servers and DB. And whenever the client sends us, like say the client wants to read a specific product, so it will send a query request to the server. The server will query this product from the DB, and the DB send it back to the server, and it will be sent back to the client. This process is good, but the cache basically will improve this process and make it even faster. So the cache will, if we add a cache server, it will basically the server will store the frequently accessed data, and since in the cache, and since the cache is an in-memory storage, it serves data way more faster than the database. So that the client will get the data, the frequently accessed data, way more faster, and this is not only improve the performance of the system and reduce the latency. It also reduce the load on the database, because right now we don't have to go through the database for each request. And I guess it's reduced the load on the database, I guess, by 80%. So the cache is pretty useful technique. Next, we want to talk about some real world examples. So let's imagine like you have a major sports final on a streaming platform, and viewers expect zero glitches. Let's say that you are watching the final Champions League. You will add web servers. Web servers are redundant and load balanced as well. The video data should be replicated across continents. If one microservice stumble, you will use like cricket breakers to protect the stream. Health checks catch server crashes early, triggering auto starts. That's reliability in action. Yeah. So next we need to talk about challenges to watch for. The first thing, you need to think about the false sense of security. So redundancy without monitoring equals silence failure. Also, we need to talk about cascading failures, like one service crash can chain react unless it's isolated. Number three, we need to talk about the stale caches, like serving old or invalid data. And four, we need to talk about the network partitions, because systems get isolated, and which is like you need to design for partial failure. Next, we want to talk about some best practices. So first, I would say that you need to design for failure, like because it will happen. You need to automate recovery, like self healing beats manual fixes, for example. You need to test failure models, which is to use chaos engineering. You need to keep users in mind, where like graceful errors, which is bigger than blank pages, I guess, or better, yeah. You need to monitor everything. Like it can't see it, you can't fix it. This is something that you need to know. So let's wrap up. So reliability is invisible when it's done right, and unforgettable when it isn't. You need to build trust with your users, plan for the worst, and your system will shine. And yeah, that's it for this video, and see you in the future.